Good morning to all. Today my topic is about I'm Anvesh from Triple Branch, and today my topic is about series and parallel resonance problems of wide band frequency harmonic and its elimination strategy. Coming to the introduction with the development of smart grid and widely used of renewable energy sources, the type and characteristics of power as well as topology of grid have changed. Obviously, therefore, power quality problem are increasingly prominent and present new characteristics. Renewable energy resources uh, connect to the grid by power conversion could lead the randomness of harmonic problems. More and more power electronic equipment applying to a renewable energy generations and flexible control technologies. Manuscripts received December 3rd, 2012, February 24th, accepted May 10th. New teacher found for the doctor station. The Ministry of Education undergraduate and planned growth of young teachers are based on the pulse with modulation control technology and converge generally based on the transistors are also gradually developed into PWM technologies. So in the smart grid, the mid order and high order frequency harmonic will greatly increase. The applying of voltage type harmonic source such as high frequencies which power sources will cause voltage type harmonic problems significant, leading to interaction coupled of different harmonic sources. It is also hard for traditional power filters to suppress current type harmonic over 1 kHz effectively. So harmonic in the grid will appear wideband characteristics, and also voltage type harmonic significantly increase the distributed capacitance of transmission lines, which has been neglected previously, will affect the harmonic problem significantly. Wideband frequency and multi-type interaction couples harmonic will bring a new challenge to operation of grid. People have been begun to explore characteristics of power quality problem in smart grid. For example, the detective power quality adapting to the digital technology, power quality in distribution network, the stability, HVDC system, the evaluation index, and reliability evaluation method of quality, power DC transmission technology, and the economic method of power quality. However, the most of studies problem are particular distributed micro source such as mechanism analysis and elimination method of problem by wind power, photovoltaic power generation of electric vehicles. Some lecturer works discuss the microgrid and the distribution system containing the microgrid. The stable microgrid system, which is used to hybrid system containing the motor turbines, fuel cells, and other to deal with frequency fluctuations, is presented in, and the work in indicates that there is an interaction coupling among a large number of microsource inverts. So it is a big challenge to adjust their power quality. In this paper, wideband frequency harmonic problem is a smart grid, and discussed in the section 2, based on the analysis in the influence of the distributed capacitance, the mechanism model of series and parallel resonance problem of wideband frequency harmonic is established, and then the resonance mechanism of different types of harmonic sources are studied. In session 3, novel topology of hybrid active power filter HAPE, where for wideband and multi-type harmonic emanating in proposed, and it is principled as resonance damping characteristics, and are analyzed in details in section 4. A control method based on the fundamental magnetic flux compensation theories described simulation experimental results have verified that novel HAPE has good performance in harmonic resonance operation. Single phase equivalent circuit of diagram. So this is a circuit of diagram of a single phase equivalent circuit of grid. Now, series and parallel resonance problems of wideband frequency harmonic. equivalent circuit of smart grid to establish an analysis model of harmonic degradation in the grid. Equivalent circuit of grid is discussed first, especially the parameters such as distributed capacitance of transmission lines and transform that the neglected previously. Will consider carefully the lumped parameter pi type equivalent circuits or transmission lines. Is difficult to describe its characteristics when the frequency of harmonic is length of line varies, so distributed parameter equivalent circuits of transmission lines is adopted in this paper. For a distribution transformers, winding parameters ZT, excitation parameter YT, and the main parameters select mainly influence its characterization, while for a high frequency transformer distribution capacitance should be considered. In the smart grid, the frequency of the characteristic harmonic is generally less than 1 kilohertz, which is far less than the working frequency of high frequency transformers. So in this paper, the influence of distributed capacitance is not considered. The single phase equivalent circuit of grid is shown in the figure 1. So when US supply voltage ZS and the equivalence impedance of grid ZT and YT, and the equivalent impedance of transformers ZT and YP, equivalent impedances of transmission lines. So accurately model parameter pi type equivalent transmission line, so in shows in the figures. So these are the figures: distributed parameter equivalent circuits of line harmonic domain, the first one, and the second one is lumped parameter equivalent circuits of transmission line in harmonic domain. And the resonant mechanism caused by voltage type harmonic. With the development of smart grid, the voltage type harmonic source has taken more and more important roles, and frequency range of harmonics also gradually increased. Shows the analysis of modal resonant mechanism when the voltage type harmonic is considered, where ZSH is equivalent equations. The supply harmonic currents caused just by the voltage type harmonic sources, harmonic voltage amplification, the primary and secondary sides of transformer respectively. Simulations as well as has been carried out. The MATLAB software shows the ratio of the supply harmonic current caused by the voltage type harmonic in the voltage type harmonic source is less than 10 power minus 4, that is supply harmonic current caused by the voltage type harmonic is very small. From figure C, and we can see this, there is a little difference between amplifications is the primary and the secondary side of the transformers. In the other word, the harmonic amplifications of voltage type harmonic source is mainly caused by the distributed capacitance and equivalent impedance of the long distance transmission lines. Analysis of model of resonant mechanism by when the current harmonic is considered. The first in this diagram, the first diagram is for electrical model of grid when is current type harmonic is considered, and the second one is impedance network when current type harmonic is considered. And series shunt PPF can compensate reactive power and eliminate the characteristic harmonic efficiently. However, there will be great harmonic current in LC series turn PPF when the grid voltage is distorted or the load contains voltage type harmonic sources. Moreover, the power factor of a AC side of PWM type inverter is generally high, even close to 1, so it has a little need for reactive power consumption. Therefore, the PPF part in the proposed topology adopts a band stop filters which is connected in the parallel and turned at fundamental frequency. The PPF presents low impedance for high order harmonic but does high impedance for low order harmonic. It is could effectively suppress the low order harmonic current flowing through the PPF when the grid voltage is distorted or the load contains voltage type harmonic sources. Consequently, it becomes the disadvantage of consequential LC series turn PPF. The impedance transfer function of parallel turn PPF can be expressed as the amplitude frequency characteristic of parallel turn PPF. It can be seen the impedance of PPF or on fundamental frequency is large, relatively small for the low frequency harmonic, but for the high frequency harmonic the impedance is very small, so it provides a current channel for high frequency harmonic and can avoid a vast low order harmonic current flowing through the passive filters when load side contain voltage type harmonic. In this paper, the APF part is in the processed HAPF is based on the principle of fundamental magnetic flux compensation method. The voltage source inverted is controlled to generate a fundamental current in the secondary side of the transformer, which could meet the compensation requirement. So the series APF present low impedance as the fundamental frequency, but the impedance of grid in harmonic domain increases, which will force the harmonic current flowing improve performance of PPF. Meanwhile, the series APF produce a compensation voltage whose the direction is opposite to the load and grid background harmonic voltage. So the series and parallel resonance inhabited. When IF and I2 is are the fundamental currents in the primary side of the transformer and the total current in the secondary side of the transformer respectively. So when the amplitude of this current injected the secondary winding is k times the fundamental components in this primary winding, in the primary being the opposite of phase, the fundamental main magnetic flux of transformer is zero at this time the leakage impedance of primary side the fundamental frequency is very small, assumed as the R1x plus jx1, while the impedance of nth harmonic n times of that further fundamental frequency excitation impedance. Generally, the leakage impedance transform is usually much less than the magnetizing impedance. The ratio of magnetizing impedance to the leakage impedance exceed 100 for the fundamental. Therefore, the ratio between transform impedance to the nth harmonic current and the fundamental current exceeds 10 to 100, and thus the forcing the harmonic current flowing into the PPF, which plays a good role in the harmonic eliminating according to the analysis above. The single phase equivalent circuit is of the proposed HAPF can be shown in the figure 11. This is so single phase equivalent circuit of the proposed HAPE. So this is a figure of that one. The amplitude frequency characteristics of Zn and ZOS. It can be seen the output impedance values of proposed HAPF is harmonic domain is capacitive and small. With the increase in frequency, the input impedance decreases. Moreover, the variety of magnetizing impedance has little effect, mainly depends on the PPF. As the value of ZOS is small, the proposed HAPE has a good performance in the harmonic eliminating. The parallel harmonic resonance also can be retained. The transform magnetizing impedance from the frequency response characterization, we can see the harmonic series resonance phenomena always does not exist as the equivalent input impedance is very large. Series harmonic resonance caused by the distorted grid voltage can be restrained. Simulation experimental result simulation result simulation has been carried out for the software. The main circuit is simulation in the figure. The supply voltage is 110 kilovolts and the length of the 110 kilovolt transmission line is 70 kilometers, and the impedance and admittance of per unit length of the line is 0.0013 millihenries and 0.004 microfarad. The equivalent impedance of 10 kilovolt system is 8 ohms 8 ohms and 20.9 milliamps. The nonlinear load in the 0.4 kilovolt system is constituted by the inductor filtering three-phase uncontrollable three filters bridge and capacitor filtering uncontrollable rectifier bridge in parallel, where DC side inductor of inductor filtering rectifier resistor 10 ohms. Other simulation parameters as well as follow. The turns ratio of the series transformer is 1:1. The output filter is of the inverter is 3 milliamps and can C is 20 microfarad. The parallel passive filters LP is equal to 8.45 milliamps and CP is equal to 200 microfarad. The DC side capacitance 1000 microfarad. Simulation results are shown in the figures. When the processed HAPF is not adopted, supply current in the 0. Kilovolt system is seriously distortion. And these are the experiment result and the platform built in the laboratory. In the experiment, the supply voltage of 0.4 kilowatts, the nonlinear load, according to distortion rated of supply current 45%, and the distortion rate of supply voltage is 5.3 B for proposed HAP is adopted, while when the proposed HAPF is put into use, the distortion rate of supply current reduced with a 2.9%, and the distortion rate of the supply voltage reduced to 1.28%. So harmonic content of supply current and harmonic voltage and significant reduced waveforms of supply current and supply voltage are close to standard sine waves, and the harmonic resonance problem can also be suppressed. Supply voltage and before the HAPF is adopted, and supply voltage and current after HAP is adopted. So these are the two diagrams over here. So last is the conclusion. The propagation rule in the wideband frequency harmonic is a grid is stupid it is studied in this paper concerning the influence of distributed capacitance as a transmission line and the transformer multi-terminal network analysis model of wideband frequency harmonic deterioration is established as, and the mechanism of series and parallel resonance problem of wideband frequency harmonic in the grid is represented a novel topology of HAPA for wideband frequency and multi-type harmonic eliminating is for processed, and electrical model of processed HAPA is established for the analysis of harmonic resonance suppression caused by the different types of harmonic simulation, and experiment results validate the relationality of theoretical analysis of the harmonic resonance problem, and also indicate that the processed HAPEF has a good damping performance for the different type of harmonics. So these are the difference over here.